In this problem, we have a bullet with the mass given. That's not going to matter for the kinematics question that I answer, but it would allow us to answer some force questions as well if we wanted. So we have a bullet with an irrelevant mass traveling 430 meters per second. It runs into a tree and accelerates at approximately a constant rate, stopping at a distance of 10.5 centimeters. So one of the really important points here is that when this bullet is embedded in the material, its acceleration is going to be opposite to the direction of velocity. That causes the bullet to slow down. So that acceleration has to carry a minus sign. What I'm trying to find in my question is the magnitude of it, which means when we answer the final question, we'll just erase the minus sign. So I have the initial speed, I have the final speed, I have how far the bullet moved as it was boring into the wood. And this is one case where the third kinematics formula is the most useful. So let's look at our basic list again. And those first two are the ones that I call the fundamental kinematics equations because they fall right out of the calculus analysis. The second two are just algebraic manipulations of the first two. And the one I'm interested in for this problem is the third one where t has been eliminated because we don't know what t is. But we do know the initial speed. We do know the final speed because it comes to rest, and we know how far it went. We know an initial and final position for the process. So A is the only unknown there, and we're going to find what we're looking for. It might be nice to be clear about where the origin is. It's right when the bullet enters the material. We're going to call that x equals 0, and then we get to x equals 10.5 centimeters at the end of the process. I'm going to write that in meters as 0.105 meters. And the two things we don't know are the acceleration and the time for the process. And in this question, we're not interested in the time. So again, I'm trying to pick the equation that has the known quantities that I possess, and then the only unknown is the thing I'm looking for. So v squared equals v naught squared plus 2a times x minus x naught. And my final velocity is 0. My initial velocity was 430 meters per second. I got to square that. A again is our unknown. And then x minus x naught, the initial position was taken as 0, and the final was 0.105 meters. So I don't ordinarily show these algebra steps because you can do it all at once in a calculator. I'm going to take the negative of 430 squared. In other words, I'm subtracting it over to this side of the equation. Then I divide by the numbers that are stuck on A, and that's dividing by parentheses twice 0.105. And I obtain an acceleration of negative 8.80, just keeping 3 sig figs, times 10 to the 5th meters per second squared. Now what we were asked for in the problem is the magnitude of that, which means you just erase the minus sign. All I care about is the size of the acceleration, not the direction. So I suppose the real answer is 8.80 times 10 to the 5th. If you find the physics content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce over 100 new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.